So let's take a look at another example, another multi-plant example. In this case, we have a demand function, but we also have two marginal cost functions. So two plants, each with a marginal cost function. But this time, one of our plants has a constant marginal cost, which is 8. Now let's take a look at what that means real quick. Let's draw that out. So here we have our first marginal cost function, which is 8. We have our second marginal cost function, which is shaped like this. And we know that the y-intercept is 1 here. And this is marginal cost 2. But we want to know what this point is. So the way we do that is we set both marginal cost functions equal each other. So we do marginal cost 1 is equal to marginal cost 2. 8 is equal to 1 plus q 2 over 2. So we end up q2 is equal to 14. So we know that at the point they intersect, we have the marginal cost function point is going to be at 14 and 8. Now, what does this mean? This means that if the quantity of output is less than 14, then everything in the firm is going to be produced at the second plant, where the marginal cost is lower than the marginal cost of the second plant is lower than the marginal cost of the first plant. But then all quantities after 14 is going to be produced at the first plant, where marginal cost of the first plant is lower than the marginal cost of the second plant. And this is what this means. And this raises a question, is how many goods are we going to produce in each plant? So this gives us two cases. The first case is if Q is less than or equal to 14, which is here, it's going to be produced at the second plant. So we know that the first plant, nothing is going to be produced there. And then the second plant, we're going to be producing however many quantities there are, 14 or less. So this is case 1. The second case is that if the quantity is greater than 14, right here, then we'd automatically produce everything in the first plant. Since we produce however many there is so we produce all quantities up to 14 in the second plant, and then all the quantities after 14 in the first plant. So we know that Q1 is going to be all the quantities minus 14, since all the first 14 units are going to be produced in the second plant. And then the rest, and in the second plant is going to be producing 14 units. First plant is going to be producing basically the total units minus the 14 units that are going to be produced in the second plant. So let's look at that mathematically. So if we look at the first case, and we basically set, so the first case is where quantity is less than or equal to 14. And we know that the revenue or profit maximizing condition is marginal revenue is equal to marginal cost. And we know that the marginal revenue is basically this formula, this equation, multiplying this term by 2, where we get the, sorry, this is the marginal revenue. So we take that marginal revenue formula, or equation, which is 968 minus 40Q, and we set that equal to the first condition. Or, yes, the first condition. And the first condition in this case will be if Q is less than or equal to 14. So we know that if Q is less than or equal to 14, everything will be produced in the second firm. So we take the marginal cost of the second firm right here and set it equal to the marginal revenue. So we have 1 plus Q2 over 2. And when we isolate for Q, we find out that Q2 is going to be equal to 23.88. Now, 23.88 is greater than 14. And therefore, we know that this condition doesn't match this assumption. So this condition does not match this assumption of Q is less than or equal to 14. And therefore, we know that there's more than 14 units that are going to be produced, and therefore case 1 is debunked. Now let's take a look at case 2. So we have case number 2, where Q is greater than 14. And therefore, we want to use the other marginal cost function now. So we know that marginal revenue is equal to marginal cost. We know that marginal revenue, 968 minus 40Q, is equal to 8. And we solve that, and we get Q is equal to 24. So there's no contradiction here. Since we know that if Q is greater than 14, which in this case it is, if Q is greater than 14, the first 14 units will be produced in the second firm, and the difference is going to be produced in the first firm. So, in this case, we know for sure, so we know that firm 2 will produce 14 units. The rest will be produced in the first firm or first factory. Sorry, this should be plant or factory. And therefore, we know that quantity 2 will equal to 14, and quantity 1 will equal to 24 minus 14 units. And therefore, 10 units will be produced at the first factory. So therefore, so far, we found the total quantity, we found Q2, and we found Q1. And as you notice here, Q1, or Q is equal to Q1 plus Q2, and we have 24 is equal to 14 plus 10, and therefore each side satisfies the equation. Now we have to find out the price, which we've done that before. So as you recall, we take the total quantity right here, and you sub Q into your demand function. To find P. So you have the demand function is equal to P is equal to 968 minus 20Q, which is given. You sub Q equal 24. And then you get price is equal to 488. And there you go. We found our price, we found our Q1 and Q2, and our Q based on these given functions.